I wanted to take a few minutes to talk a little bit more about interfaces. And there are a couple of good examples online in the Java tutorials. And so one example of when an interface is used that's a little simpler than the example that I gave you the first time I did an interface is, say for example that you have a multinational corporation that has programmers in various locations. And you might be, for example, a bank. And you might have some programmers that work on credit cards and some that work on programming for checking accounts and some for savings accounts and so on. And so there are some common things that any type of financial account is going to do. There's going to be an interest rate for credit cards, for savings accounts, and so on. So instead of having each division write their own or name their own methods, one might call it get APR, one might call it get interest rate, and so on. And then if programmers need to move around or you need to share code or something from place to place, each unit has developed its own naming convention, and that can really be problematic. So when you are in a situation like that, generally you will see somebody at a very high level in the organization will say, okay, everybody is going to have a method that says get APR. And that will return a double, and it will always return the interest rate, whether it's the interest rate being charged on the credit card, whether it's the interest being earned on a savings account, whether it's the interest earned on a checking account, whether it's the interest rate on the mortgage. Everybody understands that when they see that get APR method, it always returns a double, it always gives you back the APR, and it is always called that same name. So somebody at a high level, maybe at the corporate office in IT, would set up these interfaces, and all of the subsidiary locations, whenever they're writing code that has to do with APRs, they're all going to use that same method name, and they're all going to make sure their method returns a double. So it's a way to standardize when you're doing something like that. Very helpful when you're dealing with financial or accounting software, and you have multiple groups of programmers developing different things, but yet there are some commonalities like APR, for example. Or you might have different units that take information from customers, and you might want everybody, whether they're setting up a checking account or a savings account or a credit card account, you're going to need the customer's social security number. Well, some people might want to save the social security number in the database in numeric form. Some might want to store it as a string. Some might want to include the dashes and spaces or spaces. Others may just want to include only the numbers. So if at the corporate level you say everybody's going to treat social security number as a string, and whenever they get or set that social security number, they're going to have a get SSN method and a set SSN method. And get SSN is going to return a string. So we don't have problems with one group storing it in a numeric format, another group storing it as a string, and then if we need to share that information, somebody's got to convert. You know, if I'm storing it as an int, sending it to you as an int, but you're using it as a string, you've got to convert it or cast it. You get into those kinds of issues. But if you have an interface that spells out, you know, whenever people are dealing with customer information, I'm going to have a customer interface, and it's going to make sure that social security numbers are accessed to strings with get SSN and set SSN methods. It's a way to standardize. Everybody's going to use the same names, the same return types, so that everybody's on the same page. And that's kind of what the examples in the Oracle documentation talk about. One example talks about a bicycle company where you have a bicycle class that's an interface, for example, and it's going to have set gear and things like that in it, and whether you create a mountain bike class or a touring bike class or a child's bike class, they're all going to implement the bicycle interface, and everybody's going to call their method set gear, for example. The other example that's here, and this is the one I like, is where they're talking about, in software engineering, different groups of programmers are going to agree to a contract that spells out how their software interacts. So in other words, everybody's going to agree that they're going to set up methods with certain names, with certain return types, so that the programmers in different groups need to interact and share pieces of information or code. It's not a problem. Now, each group might have a different formula or different code, for example, for calculating APR. That can be done at the unit level, at the programmer group level, as long as they make sure that, set APR has a certain name and get APR returns a double. They are free to write their own code based on whether it's a daily APR, monthly APR, etc. But the bottom line is everybody's going to know what the naming convention is and what the return type is for certain methods. So that's the contract that's going to spell out how the software is going to interact. And therefore, this becomes a true statement. Every group can write their code without really knowing all the details of the other group's code, but they've just agreed on certain naming conventions and return types. So that's why we think of it as a contract. And so this is a pretty good example. If you had some type of situation where you had cars that had a programmable chip in them, and all the automobile manufacturers come together and say, let's all agree to certain standards, even though Ford is going to have like a slightly different spin on their implementation code, and Honda might have slightly different code, different formulas. They're all going to agree that automobiles do certain things. They start, they stop, they accelerate, they turn left, and so forth. And so as an industrial group, they say, let's not get into really sticking it to the customers by everybody having such a different programming base. Let's say that for certain things we're all going to come together, kind of like almost like semi-open source. We're all going to come together and agree that we're going to have an interface called operate car, and we're going to have certain methods in it, and those methods are all going to take the same information and they're all going to return the same data type. And that does happen in industry groups. There are situations where industry groups come together and say, each of us will go back and customize little things in our system, but we're going to agree to certain standards. When you get into the database world, there's something called ANSI Standard SQL. Every single database manufacturer, whether it's Oracle or Microsoft or Fox Pro or MySQL, they all agree that a select statement will start with the word select. It will be in a certain format. It will have the word from. It will have the word where. It will end in a semicolon. They all agree to that. Then they go back and they all tweak theirs a little bit. They might say, we're going to add a little different functionality. We're going to let you, Oracle's going to let you do a replace in a select statement, whereas Microsoft doesn't, and so on. So you have enhancements that separate each database from each other so that consumers can decide what's important to them, but they all agree that a select statement works a certain way. Well, that's the same thing here in this example. Every car is going to stop, start, accelerate, turn left, turn right. So we're going to come together as a group and agree that if we're going to put programmable chips in these cars, that some functionality is going to be the same in terms of the names of the methods and the return types, no matter whether it's a Ford, a Honda, or whatever. And so that's what they're talking about here. And that way, they can use the standard GPS and so on. And that's what they're talking about here. And so now you've got an industry standard, and the way you're going to enforce that is that everybody's going to agree to implement the interface operate car. So different companies, Ford and Toyota, don't necessarily know how each other program the various methods, and that's proprietary. But they're going to adhere to what I call the semi-open source interface. They're all going to agree to certain things here. And so what they would do is They would come together as a group and they would agree that they're going to name this interface operate car. And notice it's public interface, and there's the name, and there is my brace right there. No parentheses, just a brace right here. Now you can put constants in an interface. So if you had constants, wheel radius equals some number, okay, that's permissible. But you will not have instance variables. You will not see a declaration of radius or start speed or any of these variables anywhere in the interface. They will not be declared here. They will be declared in the classes that implement operate car. But you can have constants. You cannot have variables in here. You're also going to notice that you do not see the word public in front of any of these methods because an interface, by definition, by default, only has public methods in it. That means these methods have to be accessible by any class that implements the interface. They must be public in order for that to work. If these were private, if you had private int turn, then when you went to Ford Hovercraft implements operate car, you'd have a problem. Ford Hovercraft would not be able to access the private method turn. So that would totally blow up or ruin the idea of the interface. So because of that, we say that all methods in an interface are public, and we don't need to specify public int turn here. We just put int turn. And so we put the return type, and it could be void, int, double, boolean, string, etc. And then we put the name of the method. Then in parentheses we put all the parameters that that method should accept, that everybody agrees. Everybody agrees they're going to call their method for turning turn. Everybody agrees it's going to return an integer value. And everybody agrees it will take 3 doubles and an int in this order: radius, start speed, end speed, direction. And notice there's no brace or anything here. There's just a semicolon because this is not implemented. This is just the method's signature. The implementation will be in the class that uses the operate car, such as Ford Hovercraft. Same thing with change lanes, signal turn, and so on and so on. I can have a method. I could have a void method. I'm just not an automotive person. But say I needed to have some type of set gear method that did not take any parameters. I would just have paren, and semicolon, and that's perfectly acceptable. So now, how would I use that? Well, at Ford, their hovercraft is going to implement operate car. And I don't believe I need those parens there. I'm not sure what I was thinking when I did that. But Ford Hovercraft implements operate car. And now here in Ford Hovercraft, notice it is a class, public class. Here's where I set up any and all instance variables that I need, such as radius, start speed, whatever I want to call them. Here's where I have my constructor, and I just was in a hurry, so I put it all on one line. But notice now this is where, if I do not have in my Ford Hovercraft, if I do not have each one of these methods with the same return type and the same types and number of parameters in the paren, I will not compile. So I better have a turn, change lanes, signal turn, get radar front, get radar rear, and a set gear in these methods, and that's exactly what I did. I basically copied and pasted, and I came in here, and this is where I put the implementation or the code in the class file. So Ford can write their turn method however they want to, as long as it returns an integer and it takes the 4 values radius, start speed, end speed, direction in that order, and there are 3 doubles and an int.